I'm Vineeth.
I'm Sai Krishna.
And today we are going to show you a little project which we did, and it's called a Programmable Interconnect.
The problem statement for this project was pretty open. It was to make anything that had a practical application.
Well, most of you must be wondering what a Programmable Interconnect actually does.
Well, you can say that it's a circuit which is capable of manipulating data pathways. Isn't that right?
Yeah, it just changes the connection configuration between multiple devices.
Now, whichever definition you feel comfortable with, go for it. But the interconnect is just a clever combination of multiplexers, demultiplexers, and flip-flops.
And we call it a Programmable Interconnect because the IO mapping can be changed by the client.
Yeah, that's enough. Now, I think everyone should see what the actual project looks like. Now, let me warn you. The image that you're going to see is extremely graphic and is not at all suitable for the weak-hearted. Yeah, there it is. It looks pretty complicated, doesn't it? Well, let me tell you this. It's not nearly as complicated as it looks, and we're gonna walk you through each and every inch of it. Let's see. Starting from what do we have here? We have 8 breadboards, a microcontroller, and a laptop computer.
Oh, hold it right there. Are we forgetting something?
Really? Like what?
The applications.
Oh yeah, there's that. Yeah, since you're the one who brought it up right now, why don't you enlighten everyone with take it away?
Okay, the Programmable Interconnect has many applications. You can use that on a network on a chip, a system on a chip, or maybe even data encryption. But we're going to stick to one focal point, and that is data pathway manipulation.
That's right, folks, and the main objective of this project is to understand how it really works.
Yeah. We're going to look further into the circuit with Vignesh,
from whom you haven't heard so far.
And we're really going to bug him.
Yeah, we'll see about that. I got my bug spray ready right here. Alright people, Jim Shady and me are going to show you how this circuit works. We're demonstrating it. He's going to handle the clock manually. Now let's show you how it works. As you can see here, this is input 0, input 1, input 2 and input 3. This is output 0, output 1, output 2 and output 3. Now I am going to select input 0 and output 0. As you can see, the output 0 has lit up. Wait. When you are alternating the input, the output also changes accordingly. This shows that both of them are connected. Now we are going to connect input 1 with output 3. Alternating the input shows this connection. Now we are going to connect input 2 with output 1. Yeah, the change in output shows that the connection has been established. Now we can overwrite any input with any output. Let us demonstrate that by overwriting input 1 with output 0. Previously input 1 was connected to output 3. When you overwrite input 1 with 0, 3 should go off. Now we can clearly see that 1 and 0 have been connected.
Also, now we can note that 0 and 0 are not connected anymore. We can see that by alternating the input 0 again. See, alternating the input doesn't give any noticeable change in the outputs. So, input 0 is no longer connected to any of the outputs, not just output.
Okay, according to the selection input, the decoder will pick up particular demux, and similarly another decoder would select a particular mux. On applying the clock, a particular connection selection inputs are stored into the flip-flops and that connection would be established.
When you're assembling the circuit, try to use the chips of the same company to avoid voltage or current discrepancies.
We actually hyped it up. We don't actually need a microcontroller. We use the microcontroller to interface the interconnect and the laptop. You can actually give the controlling inputs manually.
What we actually implemented here is a unidirectional manipulation of data pathway. The extension to this project could be bidirectional data pathway manipulation, and in reality that's what happens in an SOC and an NOC. But that would require a lot more circuitry, a lot more wires and a lot more components to be involved, and the size of the project would be really big.